All right, hey you guys, today we're going to be talking about reasoning with ratios. We've been talking about ratios for the past couple of days. Remember, we are working in our yellow booklet. The nice thing is today we actually don't have to take any notes. I just want you to use some common sense with me. I'm going to show you a lot of it, and then you're going to practice on your practice paper. The first thing I'm going to do is I'm going to show you this video, and then we're going to actually ask some questions based on this video. Now, there's no volume to it, so you're just going to watch it and check this out. So first things first, you have a cup of water and we've got a couple lemons. So he's going to put one lemon inside of this cup. He's going to drink the water. All right, he's done with that one. Now he's going to grab a big cup with a lot more water in there. And he squeezes in just one lemon again. Okay, so now let's take a look at these questions. Let's take a look at these questions. Question 1, which glass do you think will taste more lemony? And what do you think? I know you're going to know all the answers to these, but you're going to probably tell me the small glass because there was less water. More lemons in there because there's less water. The second question says, what could you do to make the larger cup have the same exact lemon taste as a smaller cup? All right. You're going to put more lemons in there, right? But it's saying the exact amount. That's where ratios are going to come in. We're going to be talking about proportions tomorrow, and it's really going to make sense. But I'm going to show you proportion. I'm going to show you like a little snippet of proportions. Now it says, do you think the ratio of lemon wedges to the amount of water matters for the taste? Do you think how many lemons you put in a cup will matter? Absolutely. Because in that video, the second cup had way more water, but the same amount of lemon. We know that it doesn't taste the same. And the last thing, what do you think you need to know in this scenario in order to make the drink taste the same? What 2 things do you need to know? And today your classmates did great. They told me, well, you need to know how much water and you need to know how many lemons. That's exactly right. So taking a look here, we're going to compare what we did see. What was the relationship between the lemon wedges and the ounces of water? Remember what I said, anytime you see these sentences, I need you to put those numbers on top. So here it says, the ounces of water. How many ounces of water were up here? 8 ounces of water is blank the number or the lemon wedges. How many lemon wedges? Just 1. And remember, at the end, you need to set up your fraction. This would really be 8 over 1, which gives you just 8. And in words, we know that would be 8 times. All right, so now if we read it, it'll make sense. The ounces of water is 8 times the lemon wedges. This is true. Now the next sentence, the lemon wedges, 1, is blank the ounces of water, which is 8. If we create this fraction, we will get 1/8. And that is exactly what you write down. 1/8. It's not on your paper, I apologize. 1/8. So the lemon wedges is 1/8 the ounces of water. Now, let's actually do some math. So if we're looking here, we know we've got 1 lemon wedge for 8 ounces of water. How did we get that 64-ounce cup of water to taste the exact same way that first cup tastes? Well, this is where that proportion comes in that I'm going to teach you, a ratio. The ratio for the first one was 1 lemon wedge, correct? 1 lemon wedge to 8 ounces of water. That's one of the ratios. You're going to compare it to another ratio. This one for the big cup. Well, we don't know how many lemons. That's going to be like we don't know. But do we know how many ounces of water? We do. It is 64 ounces of water. So now we have to solve. How do we figure that out? I'm going to show you 2 different ways. We talked about it on Friday when we were using our tables. I said you could work within, going up and down in your table, or you could work outside, going from left to right. I'm going to show you both ways. Here, for example, how do you go from 1 to 8. Correct. Times 8. And whatever you do to one side, you're going to do to the other. But if you do your arrow going down, you're starting with nothing and going to 64. But you can do the opposite. Why don't we do the opposite? What's the opposite of multiplying by 8? Correct. Dividing by 8. So what is 64 divided by 8? You're right. You said 8. Let me show you another way. Let me show you this way. Do you know how to go from 8 to 64? What times 8 gives you 64? Very good. Times 8. And whatever you do on the bottom, you do on top. And what is 1 times 8? Correct. Still 8. So that is 2 different ways you could have solved this. All right. So now let's practice with another problem. Now let's practice with another problem. This problem right here. Here it says, Johnny has a water jug that holds 128 ounces of water. He adds 14 lemon wedges to his water for the taste. Does his water have the same lemon taste as discussed in the previous example? Why or why not? Well, let's set up that ratio. What was the ratio we figured out? How many lemons? 1 lemon to 8 ounces of water. Now he's telling us, what did Johnny do? Johnny did 128 ounces to 14 lemons. Now just what we did on the other side, this is the way you check it. You're gonna see, is this an equivalent fraction? That's all it's really asking you. Is this an equivalent fraction? Well, let's see. Let me see here. I could do it like this. I know 1 to 8 is times 8. Well, same thing on the other side. Is 14 times 8 going to give me 128? Let's check. 14 times 8. 8 times 4 is 32. 8 times 1 is 8. Plus 3 is 11. 112. Did it give us 112 ounces? No, they gave us 128. So is Johnny correct? No, he is wrong. Another way we could work it out, I always want to show you 2 different ways. Here's another way we could have worked it out. We could have said, how do we go from 1 to 14? Well, you know it, times 14. And if we do it at the bottom, well, what is 8 times 14? Same thing. Are we going to get 128? No, we're going to get 112, and that is incorrect. Okay, so that's 2 different ways you could have solved this. All right, so now what I want you to do is you're going to be working on your practice worksheet. It looks like this. Okay, I'm going to help you out with a couple of problems right now, just because those are the questions that I had during class, and I know that I'm not there to help you out. So for number 1, they've given you the paint mixture. So 5 parts of red paint, 1 part of white. Make sure you write those numbers in correctly for this section right here. Okay, give me that wording. Then it's going to ask you right here, I'm going to read B out loud because it kind of threw some people off. I'm going to call her Miss G. Miss G doesn't think the store mixed her paint correctly. All right, she doesn't think they did it right to make the shade of pink. What did it say up top? What did it say that you're supposed to really do? It says 5 red to 1 white. Now let's see what in our actual story it says. The store mixed 35 red to 31 white. Who is correct? Did the store do a good job, or did Ms. G say, yep, they definitely messed up? That's what you're going to be answering. Okay? Taking a look down here, number 2, make sure that you pick the correct answer. If it says the hamster H weighs, you know that it's equaling that. What is happening over here to give you H? All right? Now, I'm going to work out number 3 with you. Number 3, this was a very fun one to talk about in class today. So it says MJ is mixing 2 scoops of fertilizer, so 2 scoops of fertilizer, with 8 scoops of potting soil. I'm going to write that ratio down right now. 2 fertilizer to 8 of potting soil when planting new flowers in his garden. While he was mixing, he was distracted and accidentally mixed 6 scoops of fertilizer, 6 of fertilizer, and 25 of potting soil. So 25 potting soil. How can MJ correct the problem? How can he fix the problem? What is it that he did? Well, let's see if this is an equivalent fraction. How do you go from 2 to 6? Very good. Times 3. Whatever you do to the top, you do on the bottom. What is 8 times 3? Yes, 24. So what did he do wrong? How does he need to fix this? He needs to take out how much of potting soil? It should be 1 scoop of potting soil. Take out, let me write that down. Take out 1 scoop of potting soil. That's the way he can correct his mistake. Now, like I tell you every time, I'm going to show you another way. Another way you could have done this is up and down. How do you go from 2 to 8 times 4? Whatever you do to one side, you do to the other. And 6 times 4 would still give you 24. Okay? So we're going to be working a lot on these things tomorrow. Alrighty? So I'm going to go ahead and erase this. Remember, you can always fix your mistakes. Now, number 4. I want you to just cross out on the actual table. So for example, if this is wrong, I want you to scratch it out and put the correct number. All right, that's what you're doing for number 4. And I think from here on out, everything ran smoothly. All right, if you have any questions, remember, you just bring your questions to me when you get back to school. And if not, good luck.